You must follow all instructions and procedures found in the OPW installation manual for this product. All OPW automatic tank gauge systems and components must be installed in accordance with the National Electric Code, NFPA 30 and 70, and all local codes. All precautions must be taken to follow OSHA guidelines for working safely in a potentially dangerous environment.
Okay, one of the issues that we're seeing in the field is that you're having problems with the auto detection of the internal barrier. The problem that you'll probably notice is that when you do the auto detection in the console, you hit auto detect on the console and nothing comes up when you have an internal barrier installed in either the 100 or the 500. The biggest problem that we're seeing is that the internal dip switch number 3 has been flipped to the off position. Basically what you need to do is just power down the system, flip that back to the normal position where all of them are in a line, and go ahead and do the auto detection again. After you've checked the dip switches inside the console to make sure that the internal V-Smart is turned on, or if on the V-Smart that is connected to the unit is functioning, the next thing, if it doesn't auto detect, to make sure that the barrier is not blown. Now I'm going to flip the console this way, and what you want to do is go ahead, and I'm going to do it on a good barrier. So what you're going to do is you're going to go between power and ground, and you should get about 12 to 13 volts on that barrier position. Now I'm going to go ahead and read between power and ground on one that I have 2 probes connected, and you can see that it's about 11.5 to right at 12 volts. Depending on the length of the cable that you would have running from the console to the probes, you can be down at 10.5 to 11 volts on this particular cable. If you read the barrier voltage on the barrier as well as the good barrier, and you see that you have voltage and it's not at 0, then you should be okay. One of the things that you might want to check if you don't have voltage on the barrier itself, make sure that the ribbon cable is actually plugged in snugly on the board. Now, this is a hot console. The worst thing that you can do in the field is actually just go out and grab your linemen and just cut directly across the wires themselves. Because basically what you're going to do is you're going to short the power and the ground together, and you're going to actually blow the barrier. If you're reading 0 volts on the barrier, then you've gone ahead and you've blown that barrier. What you could do is just go ahead and move this wire to an open barrier position and go ahead and rewire and do an auto detect. What a lot of technicians will do in the field is that if they want to remake this connection on a single probe, the same thing they'll do is they'll cut across the probe wire doing the exact same thing, and then they blow the barrier. So if you've done that, go ahead, change it to an empty barrier position on the barrier, and then go ahead and have someone order another barrier for you. But please don't go ahead. If the console's hot, do not cut across. One of the things you can do is actually come into the console, turn power off. The lithium battery will continue to power the main board and the CF card, but what it does, it actually drops power to the barrier itself. At that point, you can go out in the field and redo your splices without worrying about blowing the barrier. But you're only going to have about 7 to 10 minutes to get this done. In any case, the unit will power completely down, and then you'll have to go through a complete reboot coming back. But if you do power it down, redo your splice, I can go ahead and take my meter and run it either on the barrier, and I've got 0 volts, or I can actually wire it in the field and I get 0 volts. The next thing you want to do is come back out to the field. You know that the red wire is your power wire, and then the shield is the ground. Go ahead and read voltage out in the field to make sure that you still have voltage coming from the wire and that it's not broken. And you have the exact same voltage from the barrier that you do on the end of the wire. The biggest problem that most people are doing out in the field right now is they're actually wiring it up where I have the power of one and the signal together. So it's almost like they're trying to wire the probes in series instead of in parallel. But when you are wiring this in the field, you really need to make sure that you're wiring it up, the blue to the power, the brown to the black, and then your black and the shield of the probe cable to the shield wire of your home run back to the building. Now you can't mix sensors and probes together. You have to wire all of your probes on one wire. all of your sensors on one wire. And the limitation is that I can have 4 probe wires connected to one wire running back to the building, and I can have up to 16 sensors running back to the building on one cable. You need to make sure that the cable that you're using, the 88760, is good for 1,000 feet. And the 8861, which is the 22 gauge version of the same cable, is good for 500 feet. Now, the one thing that you have to remember is that it's total length of wire. So if you do have home runs coming back to the building, make sure that your total wire does not exceed 1,000 feet if it's 8860, or 8861 would be 500 feet. And if you're having problems doing the auto detect, go back out in the field and disconnect some of your devices. Connect them one at a time and make sure that you actually have voltage on all of your home runs back, and then see what you can find, because you might be exceeding the 1,000 foot or the 500 foot limitation. If this isn't the case, go ahead and call tech support and see if they can step you through a couple of more troubleshooting techniques.